Welcome to this video where we're going to look at forming and solving an equation. Now, these sorts of questions tend to come on paper 3 of GCSE, the more problem-solving type paper. So you're often given some information, written information, and you have to convert it into algebra and possibly use some diagrams to help you understand what's going on. So we have a problem like that here. And it's worth spending a few moments reading through carefully and highlighting some key information. So we've got two triangles, P and Q, with the same area, okay? Now that's important. The base length and height of triangle P are equal. Okay, so whatever the base length of triangle P is, its vertical height, right? So when we talk about the height of a triangle, we mean the perpendicular height, straight up from the top to the base. Okay, and they're equal. Triangle Q has a base length of 2 centimeters less than P, and it has a height 5 centimeters greater than P. Calculate the area of one of the triangles. Well, if both triangles have the same area, then obviously it follows that you could calculate the area of either one because it would be the same as the other. All right, so let's make a start. And I should say at this point that we do not approach this sort of problem with trial and improvement. In other words, guessing and testing it out and then having another guess. That is not the method that you should use, and it won't get you any marks. Okay, you've got to form and solve an equation and do it algebraically and correctly. So I'll just bring in a couple of triangles here, and we'll try and create a sort of an image of what this problem looks like. So there are our two triangles. At the moment, they're both equilateral triangles, so we can work on that. One of them is quite tall and thin, okay, and the other one, let's make it a bit larger, that would be our triangle Q, okay, because it's 2 centimeters less and 5 centimeters higher. This one needs to be adjusted a little bit because it has to be, let's make this wider this way, okay. So it's got a longer base, but a shorter height, okay? And I need to bring this down a bit because it's the vertical height that has to be the same as the base, okay? So it's something like, well, in fact, it's going to be something like that, okay? It's going to be something like that. Yes, so the length of this is the same as that vertical height. So it's not an equilateral triangle, in other words, okay? Right, so it's something like that, and we've assumed they're isosceles triangles. They could be right-angled triangles. It actually wouldn't matter because it doesn't say, but it won't change anything. Okay, so let's put some dimensions onto here. So the first thing I'm going to do is I'm going to introduce a variable to represent the length of the small triangle P. And I'm going to call this here x. Okay, and therefore I'm going to call the height of the same triangle x as well. Okay, because we know that from the information given that the height of this triangle is the same as its base. Okay, so that's got a height of x as well. All right, and it's very important that you make it clear that you mean the vertical height, not the sloping height. Okay, so this is triangle P here. Now triangle Q has a base of x minus 2. Okay, and a height of x plus 5. Okay, and it's fairly easy to work that out from the information given in the question. But what you have to do is you have to do it. You have to show that you understand the question by recreating ideally a diagram like this and then forming an equation with your algebra that you've introduced. So this is x plus 5, you see. Okay, and this is triangle Q. So that's the situation outlined with these diagrams and a bit of algebra. Now, you've got to calculate the area of one of the triangles, but you need to find out what x is before you can do that, and you need to solve an equation. Well, you know that the areas are equal, so let's make an expression for the area of P and the area of Q and set them equal to each other. So area P equals area Q. Okay, that's a fact that's given to us in the question. And then we can say that the area of A is a half base times height. So it's a half of x times x, which is a half of x squared. Okay, and the area of this one is a half of base, right, which is x minus 2, times its height, which is x plus 5. Okay, now there are certainly marks for forming an equation like this. That would carry quite a few marks so far, just by writing all this down. Okay, now we have to process this further. So half x squared, the first thing I can do actually is, because they both have a factor of a half in them, I can just take that out, okay, and that removes the half. I'm basically taking multiplying both sides by 2, and I can therefore say that x squared equals, now if I just write it again like this, so I'm doing this very thoroughly and fully at the moment, okay, x plus 5 like that. Now this needs to be multiplied out using first outer inner last FOIL. Okay, so x times x gives me x squared. Then I've got plus 5x and minus 2x, which is plus 3x. And then I've got minus 2 times 5, which is minus 10. Okay, now you'll notice both sides of the equation have an x squared. So all I need to do is subtract x squared from both sides, and I get that 0 equals 3x minus 10. Okay, all right, so now if that's true, if I add 10 to both sides, 3x equals 10. Okay, and therefore x equals 10 thirds, or 3 1/3. Okay, so we've now found the value of x that makes this situation true. Well, all we need to do now is calculate the area of one of the triangles. Now we can assume that whichever one we substitute into, we're going to get the same answer for the area, because we are expecting them to be the same area. Now it's obviously easier to use triangle P, because substituting into there is going to be a lot easier than into this one. So I would say area of P, so let's move over here. So area of P is equal to a half base times height, which is a half x times x, so it's a half of x squared, okay, which is a half of 10 over 3 squared, okay, and that's equal to a half of 100 over 9, okay, and 100 over 9, well, we just need to write that as 50 over 9. Okay, 50 over 9 centimeters squared. Okay, now it doesn't say give your answer to 3 significant figures or anything like that. If it did, then it would likely be on a calculator paper, although this is not particularly difficult to carry on. But leave it like that because that is the answer and it's in exact form and it's an area, so that's it. Now, if you had time in the exam, you could check that it worked for this triangle as well by substituting 10/3 for x into here, and you should get the same answer. Okay, but everything we've done seems sound and secure, and it's leading to that answer. Question like that probably carry 5 marks, and most of those will be for setting up the diagram and the algebra and the equation to solve at the beginning. Okay, I hope that was helpful. Take care.